This is an informal video to troubleshoot a problem brought to my attention by one of the channel subscribers. Dan is trying to do a spatial analysis of molecular variance. I'll put the link to a tutorial about it in the show notes. The issue that he is encountering is that he gets an error message. Let me show you what the error message is that he gets. Let me try that again by actually typing it in correctly. Underscore. It says no vertex found for a bisector. So that's a big clue. Keep that in mind. Let's take a look at Dan's Harlequin file. He has 68 different individuals in his file for which he has DNA data. Let's take a look at his geo file. And everything looks great. There is his longitude, latitude data. Everything is formatted properly. And there are 68 specimens. What Dan found out as he was troubleshooting this problem is that if he cut his data set in half, that it would run. So let's take a look at that. His smaller version of the data set has 32 individuals rather than 68. And if we look at his geo file, which is in the same order, and let's compare it to the original geo file. So what he did was, if we look at number 32 on this list, it's CC, 32 on this list, so he cut off all of these individuals here. So again, we're going to look now at Dan's smaller data set that only includes 32 individuals, where he just randomly cut out the individuals numbers 33 through 68. What he found was that it runs. So there's something about that larger data set that was preventing it from running properly. A few possibilities come to mind. One is that his data set contains too many specimens. So maybe SAMOVA is limited to doing fewer than 68 specimens. Maybe 32 specimens is the upper limit, which would be very unfortunate. Another possibility is that there's some problem with the geometry of his data, and we'll talk more about that. Yet a third problem I forgot to mention is it's possible that his sequences are too long. So maybe he has too much sequence data. So maybe it's not the number of specimens, maybe it's the length of his sequences that is causing SAMOVA to choke and give a weird error message. So to troubleshoot, one thing that I did is I created dummy GPS coordinates. So this is his full data set, specimens numbers 1 through 68. And here are his GPS coordinate columns. This is longitude, this is latitude. Rather than using real longitude and latitude data, I put in dummy data. So each one of these individuals has a unique coordinate. And these data points are spread out. If we were to graph this, it would look very interesting. So with the fake coordinate data, the arrangement of the specimens on the landscape looks like this. So that's very, very artificial. But when you do that, it runs. So here it is, I have it running. So it runs. So this tells us a couple of things. Well, if you look at the data I used, so that was the data I used for the geography, the geographic coordinates. But if you look at the specimen data that I used, it was the same specimen data that he had originally. It has all 68 specimens with all of their original names and all of their original DNA sequences. So the only thing I did to make it run was I changed the geometry of his specimens to that really contrived artificial geometry that I showed you before. So this tells us that it's not a problem with the number of specimens that he's using, and it's not a problem with the length of his DNA sequences or some problem with his DNA sequences. That it has to do with the geometry of his coordinates. So let's take a look at the actual locations of his specimen. So here's the locations of his actual specimens. It's a little unusual in that he has one group of specimens that are all over here and spread out, and then he has one group of specimens over here that are all clustered together. I suspect what's happening is that this software is creating some sort of triangles based upon these points to calculate the similarity of these points genetically to one another, something like that. And these triangles, if the shapes of the triangles is such that one of the lengths of the triangles is almost 0, that could give you this weird error, bisection error that we're seeing. So I think it's that the unusual geometry here of having one group of points that are all spread out like this in a line and another group of points all spread out like this in a circle is has twisted the geometry to its limits in the calculations. I suspect that there's some triangles where one of the sides of the triangles is extremely short and that it's being rounded down to 0. And so it's creating this bisection error. If you look at Dan's smaller list of points, so here's all of his points, and here's the smaller list. When he used a smaller list, not with the dummy geography, but with the real geography, but where he randomly took out half. Notice that a bunch of these points here at the extreme are gone. So let's look again. So a bunch of the points up here at the extreme are gone. A point over here at the extreme is gone. I suspect that that means that there's less of this extreme geometry in these triangles, such that we don't have any of the lengths of any of these triangles that are being calculated being rounded down to 0. So so we've ruled out a problem with the with having too many samples or with his DNA, and it's a problem having to do with the geometry of his data. That's what I believe. I also tried redoing his geometry file to rule out some problem with the formatting of his geometry file, and that doesn't seem to be it either. So here's what I suggest. I suggest that Dan first make a data set that includes only these points, and makes a second data set that includes only this long group of points over here, and that he runs a SAMOVA just on these points and a SAMOVA just on these points. And actually, before he does that, I would recommend that he in fact use his rarefied data set, which is randomized, and that he say, look, I know that I have at least two distinct subregions. I have a subregion over here of populations, and I have a subregion over here of populations. So without looking at the fine scale differentiation of within each of these two subregions, I'm first going to compare one subregion to the other, and I'm rarefying the subregions to prevent SAMOVA from encountering problems with the geometry. So that's the way I would write it in the manuscript, or for whatever formal scientific publication this would be used. That first thing you did is you noted that there were two distinct regions, and that to prevent problems with the geometry of the calculations, you rarefied the points within the two regions. And then what I would do is I would color code all of these individuals as belonging to either one region or the other, or call them populations. So in this rarefied data set, I would only have two populations, this one and this one. And then I would run SAMOVA on it to tell you if in fact that it's true that this is one subpopulation, or that this is one distinct region genetically and geographically, and this is another distinct region genetically and geographically. Great. And then you would say that you're doing that to prevent geometry problems when running SAMOVA on the full data set. Fine. So then what you're going to find is SAMOVA is going to tell you that you have, I predict, that you have two major populations, one here and one here. And that'll be based upon the rarefied data, where you have all these coded as population 1 and all of these coded as population 2. Fine. Then you can say that as a follow-up, you looked within each of those two major regions and performed a separate SAMOVA to find the separate, I guess you could call them populations, within each of those subregions. So you do one SAMOVA for here, where you have all of the populations correctly coded as to what populations you think they're from. And then you have all of this together coded so that, as you did originally, but you just be running it on the two separate data sets. And then you would let the SAMOVA tell you what the actual populations are within this subregion and what the actual populations are within this subregion. So there you have it. I hope this is useful to others, and Dan, please reach out and stay in touch and let me know if this worked for you. This was very helpful for me as well to learn more about this problem with SAMOVA should I encounter it in my own research. So I thank you for bringing it to my attention, and I encourage others to do the same.